to Math Expert video tutorial, and in this video we are going to look at half-angle identity. Half-angle identity. In fact, the moment you hear the word half-angle identity, what comes to mind? You see, we are still manipulating on the argument. Some and different product and whatever, it's all about the argument. So here we are saying that from the alternative forms of the identity for cos 2a, we derive 3 additional identities for when we're doing double angle. We derive 3 identities for cos 2a, and one is cos square a minus sine square a, and the other one is 2 cos square a minus 1, and the other one is 1 minus 2 sine square a. Yes, it all have to be in your head. Alright, it all have to be in your head. Very good. So, in the same way, if we can get a double angle, then we can also get a half angle. Alright? We can get sine a over 2. We can get sine a over 2 cos a over 2. And also, we can also get, it is possible to get tan a over 2. Tan a over 2. It is possible to get that. Very good. So now, let's start to derive the identity for sine a over 2. So where are we going to even start from? So we start with the following double angles identity for cosine and solve for sine s. So now, to get it, we know that cos 2s is equal to, we are taking the one which is in terms of sine because we want to prove that for this. We want to get the half angle of sine, So 1 minus 2 sine square a. Very good. Now, since we want to get, we are proving for half angle for sine, let's make sine the subject. So we get 2 sine square a to be equal to 1 minus cos 2x. Very good. Then with this, what do we do now? Here, since we are looking for sine, we divide both sides by 2, or we multiply both sides by 2. So when you multiply this we multiply both sides by half, and it will give us sine square a over 1 minus cos 2s. I like using s too much. Oh. So all these over 2. Now for us to get sine a, but because we are looking for sine a over 2, the over 2 will come later. But for us to get only the sine, we take the square root of both sides, and that is going to be plus or minus 1 minus cos 2a, all this over 2. Don't forget the plus or the minus. Now, why do we bring the plus or minus? Hope you can tell me. Oh, you will tell me. Yes! Because for it to be plus or minus, depend on the quadrant in which this is going to fall. It will depend on the quadrant in which this is going to fall. Alright. Now here, since we are looking for sine a over 2, we now divide the angle of a by 2. Not only this, but any argument, or for all the arguments, we we are going to divide it by 2. So let me write it on this side. So sine, then we divide this argument by 2. When you divide it by 2, then you have to do the same thing for this. So here too, you are going to get half times 2a, all this over 2. Hope you can see that. And finally, we are going to get here to be this cancel this. So to be left with a. To be left with a. Very good. So this establishes the half angle for sine. The half angle for sine. Without wasting much time, let's move on for cos. The half angle for cos. So that's that. So please make sure you jot it somewhere. That's the half angle for cos. Okay. So we go for half angle for sine. So we go for cos rather. So where do we start from? Okay, so we are starting from the same double angle, but instead of giving the one in terms of sine, here we are going to give the one in terms of cos, because we are putting that for cos, and that is that. Then we make cos where a the subject, and we are going to get 1 plus cos 2a. 1 plus cos 2a. Very good. So here cos square a will be equal to 1 over half multiplying 1 plus cos 2a. And when you take the square root of both sides, you are going to get plus or minus 1 plus cos 2a, all this over 2. All this over 2. Very good. Then we divide the angles. So don't forget that this one too is an identity, but here we are basing on the half angle. So cos a over 2. So we divide here by 2. Then here will be plus or minus 1 plus cos 2a, all this over 2. So here it will no more be 2a but rather a, because you multiply the 2a by half and that will give you a. Very good. So that is for cos and that is for sine. Wow. What is the difference between this and this? 1 plus 1 minus. That is the difference because this and this they are the same. And it's all having a denominator of 2. Very good. So let's go for the last one, which is tan. Which is tan. So that is how we prove it. So I like doing trigonometric identities. It makes you understand the content very well. Okay. You know that tan. Now for us to get tan a over 2, we divide by sine a over 2 over cos a over 2. Sine a over 2, that is plus or minus 1 minus cos a over 2 over plus or minus 1 plus, that is the cos, 1 plus cos a over 2. So dividing this by this is the same as writing plus or minus 1 minus cos a over 2 over 1 plus cos a over 2. So 2 cancel 2. And you end up by getting the half angle for tan. the half angle for tan to be tan A over 2 to be equal to plus or minus. Don't forget bringing the plus or minus. 1 minus cos A over 1 plus cos A. Very simple and precise. That is going to be the half angle for tan. Very good. So we derive our alternative identity for sine tan A over 2 using the double angle identity. Very good. Now, this one is from the half angle identity that we have when we divided by it and we go away. Now we have another identity also for half angle for tan, and that is by using the double angle identity. So let's go and look at that one also. Let's go and look at that one. So this one gives the half angle of tan, yes, but there is other ones also. In fact, let me give you that for you to go and do it on your own. Or very good. So let me give it to you so that you go and look at. You go and look for the rest. You go and look for the proof on your own. So tan half over 2, we can also get it to be equal to sine A over 1 plus cos A. Sine A over 1 plus cos A. And tan A over 2 can be also be equal to 1 minus cos A over 1 minus cos A over sine A. Very good. So we have three identities for the half angle for tan. And that's that. So now we move on to look at how we use these identities to solve some questions. Then we proceed for the day. Very good. So let's look at that. Let's look at that. Good. So let's look at how we do this. Find the exact value of cos 15 using the half angle identity for cosine. We know that the half angle identity for cosine is that's going to be 1 plus cos A over 2. That's going to be the half angle for cosine. Now you can see that what we have here is cos 15. So we have to manipulate in such a way that, or we need to find A to do the substitution back to this. So look at this argument and this argument. This is cos A over 2. This is cos 15. So we equate A over 2 to be equal to 15. Then we find for A. So by cross multiplication, we get A to be equal to 30 degrees. We get A to be equal to 30 degrees. Therefore, we go and do the substitution back. How we can say? Just equate the two arguments and find for A. So we're going to get A to be 30 degrees. So this means that cos half times 30 degrees, cos half times 30 degrees is going to be equal to, let's take it to 40. So 1 plus cos 30. I hope you can see that. 1 plus cos 30, which is over 2, because wherever you see A, you put 30 there. And this is going to give you simple, when you punch on calculator straightforward. But you need to go through the steps. Alright, let me take my time and give it to you. When you do this, you're going to get 1 plus square root of 3 over 2, or square root of 3 over 2, all d divided by 2. Very good. All d divided by 2. Now, we can achieve the same denominator here, that is 2 over 2. Very good. And this is the same as 2 plus square root of 3 over all over 2, or this over 2. And this is the same as over 1. So here we end up by getting 2 plus square root of 3 over 2 times half. Alright? And that is simply going to give us square root of 2 plus square root of 3, all this over. Don't forget 2 times 2 is 4, and square root of 4 is 2. So here we get 2. That is the exact value for cos 15 when you use the half angle. Very good. Let's look at the second question. Find the exact value of tan 22.5 using the identity tan A over 2. Oh, okay. So here, the same way, we have to go for the exact value of tan 22.5 using the half angle of tan A over 2 to be equal to, you know that we have 3 identities, and the question is specifying us to use this sin A1 plus cos A. Very good. So that's not going to be any problem. That's not a problem. Now what we do is that here we equate the two arguments. So we have 22.5 to be equal to A over 2. Then we find for A. So A is going to be equal to 2 times 22.5. And we are going to get A to be, okay, we are going to get A to be 45. Then we are going to get A to be 45 degrees. So from here, wherever you see A, put 45 there. Wherever you see A, put 45 there. So tan 45 over 2, tan 45 over 2 is going to be sin 45 degrees, sin 45 degrees over 1 plus cos 45 degrees. Alright, very good. And we know that sin 45 is square root of 2 over 2, and here 1 plus cos 45 is square root of 2 over 2, square root of 2 over 2. So here we end up by applying our algebra. Oh, crazy of that. Alright, we end up by applying our algebra. So this will be 2 over 2 so that we can get the same denominator. So this is square root of 2 over 2. The whole of this will be 2 plus square root of 2 over 2. And the 2 will cancel the 2. So we end up by getting square root of 2 over 2 plus square root of 2. Very good. Now, when you get this, when you get this, that's not all. That's not the exact value. It's exact value, but not the exact. So we need to go and rationalize this. Okay? We need to go and rationalize this. And when you rationalize, square root of 2 over 2 plus square root of 2 times 2 minus square root of 2 over 2 minus square root of 2. And this is going to give you square root of 2 multiplying 2 minus square root of 2. Alright? And the whole of this is going to be equal to 2 square minus square root of 2 all square. So we end up by getting square root of 2, 2 minus square root of 2, all this over 4 minus 2. And 4 minus 2 is going to give us 2. Beautiful! Therefore, we get square root of 2, 2 minus square root of 2. All this over 2. 2. Very good. Now, and let me check what is going on here. Okay, now we can multiply this throughout. Okay. Hey, so let's continue again. So yeah, when you multiply throughout, you get 2 square root of 2 minus. Now, square root of 2 and square root of 2 is 2. All this over 2. So yeah, you can factor 2 out, you get square root of 2 minus 1. Okay? All this over 2. So these 2 cancel these 2, then you end up by getting, okay? So that's going to be the final result. For that, should I give you this for you to go and do it? Okay, let's look at this. Given cos S, given that cos S is equal to 2 over 3 with 3 pi over 2 S, that's the interval, 2 pi, find cos S over 2, that's the half angle, sine S over 2, and tan S over 2. So we have cos S equal to 2 over 3. Then now, what number is it? That is 4th quadrant because this is 270 and 360. So that is 4th quadrant. So on the 4th quadrant, cos is positive. That's why we have it to be positive. Very good. Now here, let me come back to my screen and explain to you well. So that is our next example. Okay, so here, the first thing to do is to get, we are saying that 3 pi over 2 less than S. That is, what am I writing? What this means is that the angle, let me change this to X. Because X. Alright, so we are saying that the angle the angle X is in the 4th quadrant. Watch. What are we to find? We are to find cos X over 2, sin X over 2, and X over 2 within a certain interval. Alright, now, don't forget that this X is not the same as this. So we need to go for the range. The range for X is 4 quadrant, no problem. But the range for half angle of X is unknown, so we need to go for that. So we need to go for the range of half angle of X. This is the range of half angle of X. If you use that to solve the question, please, you are wrong. So for us to get that for the half angle, we go and divide here by 2. And in equation or inequality, what we do to this, I do the same thing for this. So here we get 3 pi over. Now 2 is there already, then we multiply by the 2. Alright, so we are divided by half. So 2 will multiply this. Then here we get 2 pi over 2. So we are going to end up by getting 3 pi over 4 x over 2. Then here we get half. Alright, very good. Now, you can see here that x over 2 terminates in, so this is what it means. Let me demonstrate to you here small all that I'm talking about. Very good. Now, that's it. So, we have two angles here, the one for x and the one for x over 2. So, for x, for the angle x, it's in the fourth quadrant. That means that from here to here, that is in the fourth quadrant. So, if you think you are working in the fourth quadrant, you are wrong, because what you are finding is half angle. So now, watch. When you divide both sides by 2, in order to get the half angle of the x, you end up by getting 3 pi over 4. And x over 2 being being less than 3 pi over 4, and being greater than 3 pi over 4, and less than pi. So this means that the angle x over 2, that is the half angle of x, terminates in the second quadrant. Hope you can see that. Terminate. This is 180, and if you don't notice, just multiply to compare to degree, and you see what it is. Very good. So you can see that that terminates in the second quadrant. So that's also going to be from this side to this. So this is going to be x over 2, and this is going to be x. Alright? So the angle x terminates in the fourth quadrant, but the angle x over 2 terminates in the second quadrant. Thanks for your understanding. Very good. So we go for that. So let's continue. So now that we have established on that, then we move on to find it. Okay, so we know that sine x over 2 will be 1 minus cos x over 2. 1 minus cos x over 2. And we are given that cos x is 2 over 3. All this over 2. So when you simplify, then you're going to get square root of 6 over 6. Then you go for cos x over 2. And that is 1 plus cos x over 2. And this is going to give you and that is square root of 30 over 6. So that's the exact value. Then lastly, you go for tan x over 2. And that is sine x over 2 over cos x over 2. And that's going to be square root of 6 over 6 over square root of 30 over 6. This cancel this together by getting square root of 6 over square root of 30. Very good. Then when you rationalize, you end up by getting square root of negative. I'll do that. Then you end up by getting square root of 5 over 5. Alright. Now you can see the solution. So here, that is what the final results we are now coming. So if you think we are working in angle x, you'll be thinking that we are working in the fourth quadrant, and therefore only cos is positive and the rest is negative. Please, you'll be wrong. But it is telling us that we are working in the second quadrant, whereby only sign is going to be positive in the second quadrant. All students take tableau. Only sign is going to be positive, so this will be negative, this will be negative. Then that is the final result for that. So that is all. So notice that it is not necessary to use a half angle identity for tan x over 2. Once we find sine s over 2 and cos x over 2. You don't need an identity to go for this. You can just divide this and go your way. However, using this identity will provide an excellent check. Using this identity to provide an excellent check. Very good. Let's look at the last question. How? Let's look at the last question. Simplify each expression. All right. Let's see how we are going to solve our last example. How we are going to solve our last example. Very good. So what do you think? So you can see that the A is an identity for a right-hand side of a function. Because we know that cos, here is plus, so that is cos A over 2 is plus or minus 1 plus cos A over 2. Oh, I'm using A. Let me use X. So you know what this means? Very good. So now, what this means is that we are going to replace, or let me write it. You let me use A in this formula because I'm just quoting an identity, so I can use. So now we are going to replace. Here we are going to replace A to be equal to 12x because that's the argument here. Okay, very good. So just do that and see what you're going to get. So you're going to see that cos 12x over 2 is going to be equal to plus or minus 1 plus cos 12x, all this over 2. So the right hand side is exactly what we have here. So let's take this side and solve. So we see that that is going to be simplified to cos 6x. And that's going to be the final answer for that. Very good. Simple, 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 simple. Simple, simple, simple. Alright, so just know that this is the right hand side and that you are working on the left hand side. What about the last one, the B? The B also here, we use the third identity, that is tan A over 2. You can see that both of the cos and the sin, none is in this form. So you know you are going for tan. So we know that here, you just identify the A, and the A is going to be 5x. So when you replace that, you are going to get tan 5x over 2, tan 5x over 2 equals 1 minus cos 5x over sine 5x. So we solve for the left hand side. So this simplifies to tan 5x over 2. And that is all for double angles. Thank you. See you in the next video. Now in the next video, we are going to look at, let me introduce to you. We are going to look at before this. Okay. We are going to look at how to express before this. Alright, we are going to look at power reducing formula, the T formula, and all that. Now, don't forget, we are going to use the idea we have gained here to do that. That is power reducing formula. And after that, we will go to maximum and minimal value of trigonometric expressions. Then, when we are done with all these things, then we move on to the last part. That is inverse trigonometry. Inverse trigonometry. And after inverse trigonometry, we go to solving the equation to allow this thing. See you in the next video. Hey, I love you. See, we have a lot for you. So please don't forget to go to YouTube, search Math Expert. Math Expert. Be there for you. Reaching the world with the beauty of mathematics. That is our mission. go and subscribe to our channel. Please subscribe. Subscribing is free. There is no charge to subscribe. Just subscribe and hook with that to the end of this course. And trust me, it will amaze you. See you.